Okay, so for geometric series, if Sn is t1 plus t2 plus g3 is a geometric series, then Sn equals a into 1 minus r to the power of n all over 1 to the power of r. Now, this is the form we're going to use, okay? And it's used primarily when r is less than 1, but we can find out we can use it for both of them, okay? So what we're going to get is find the first three terms of geometric series are 64 minus 32 and 16. But what we can find out is that a is 64. We can also find out that the difference between each one is going to be minus 32 over 64, which is minus a half. So r is equal to minus a half each time, or 16 divided by minus 32 is also minus a half, and that's r. Remember, r is the same thing as t2 divided by t1, or t3 divided by t2, or t2 divided by t1, t4 divided by t3, or tn divided by tn minus 1. Remember, it's the same thing. Okay. Now find in terms of tn. The tn is a or n minus 1, which is going to be 64 multiplied by minus a half to the power of r, to the power minus a half to the power of n minus 1. Now, so that's question 2. Now, next one. Find Sn. Okay. Well, Sn is the formula we were discussing a second ago. Sn equals a by 1 minus r to the power of n all over 1 minus r, and therefore a is going to be 64 multiplied by 1 minus minus a half to the power of n all over 1 minus half. 1 minus a half. Okay? Now minus a half is 3 over 2. Okay? And then 64 divided by 3 over 2. Well, we can put that into the calculator. And we get there's 128 over 3. 128 over 3 bracket 1 minus a half to the power of n in the bracket. Okay, so that's the answer to that one there. Now we can move on. Now, next part, find T10. Well, T10 is replaced n with 10. So we're going to get is T10 equals 64 to the power of minus a half to the power of 10 minus 1, which is the power of 9. So 64 by minus a half to the power of 9. Power of 9. What we get there is minus 1/8. Okay, so minus 1/8. Now that we know that that's minus 1/8, find S10. So S10 is the sum of the first 10 series, T1, T2, T3, all the way up to T10. We can see that the numbers are getting smaller each time. So this time we replace this formula, Sn, and we replace n with 10. So we get Sn, or S10, equals 128 over 3 into 1 minus a half to the power of 10. So let's do 1 minus a half to the power of 10 first. Half to the power of 10. Or minus a half to the power of 10, excuse me. And then what we get there is this number here. Then multiply that by 128 divided by 3. And what we get is 341 over 8. So S10 equals 341 over 8. Okay, so that's question 2 done. Now we're on to question 5. Oh, sorry, we'll do question 4. Now question 4 is 6, 4, 8 over 3. Okay, so we need to find out what the R is. Okay, so R is equal to T2 divided by T1, which is 6 over 4, which is the same thing as 3 over 2. It's also the same thing as T3 over T2, which is 8 over 3 divided by 4. Okay, sorry, it's 4 over 6, not 6 over 4. 4 over 6 is 2/3. And that's 8 over 12, which is the same thing as 2/3. So we figured out that R is 2 over 3. We've also figured out that A is 6. So we just need to find out what Sn is. So Sn is going to do it the other way. Sn equals A into 1 minus Rn all over 1 minus R. It's going to be 6 into 1 minus 2/3 to the power of n all over 1 minus 2/3. And then what we get here, it's going to be 1 minus 2/3 is 1/3. 6 divided by 1/3 is 18, so it's going to be 18 into 1 minus 2 over 3 to the power of n. Okay. So that was question 4. Now we're moving on. So now we've done 2, 4, and this is 8. Now R equals 1. Now what we're going to do is we're going to find out, do we want to find the sum of a series, this series here, where Tn or Tr is 2R plus 1. And they want the sum equals, when I add all the terms together, at one point or another it eventually equals 508. But I have to figure out when do I need to stop it in order for it to be 508. So what I do is I find out what T1 is. T1 is 2 to the power of 2, because you replace R with 1 and you get 4. T2 is 2 to the power of R is 2, 3, and we get 8. Then T3 obviously is 2 to the power of 4, which is 16. So we know that A is 4, and we also know that T equals 2. We use our Sn formula. A into 1 minus Rn all over 1 minus R. And what we're going to get here is we're going to get 4 into 1 minus Rn all over. Now, R is 2. So 2 to the power of n, excuse me. All over 1 minus 2. So what happens here is we're going to get minus 4. So it's going to change it to minus 1. 4 divided by minus 1 is minus 4. Minus 4 to the power of 1 minus 2 to the power of n. And this answer for S of n has to be equal to 508. So what I'm going to do is going to divide 508 by minus 4. What I get there is minus 127. Minus 127 equals 1 minus 2 to the n. Bring over the 1, that's a minus. So then minus 2 to the power of n equals minus 128. 2 to the power of n equals 128. Now how many 2's when you multiply them together give you 128? Well, I can log both sides. Log 2 to the power of n equals log 128. Bring the n to the front. N log 2 equals log 128. And n equals log 128 all over log 2. So log 128 divided by log 2 goes 7 times n equals 7. The other way to do it would have been 2 to the power of n equals 128. So you could say 2 to the power of 4 is 16, power of 5 is 32, power of 6 is 64, and power of 7 is 128. Okie dokes. Moving on. So we've done 2, 4, 8. Now we're doing question 10. 2, 4, 8 and 10. The third term T3 of a geometric sequence series is minus 63. The fourth term T4 is 189. Find the common ratio and find the first term. So look, T3 is 163. So T1 and T2 over there. Then T4 is 189. R equals 189 divided by 189 divided by minus 63. R therefore equals minus 3. Now that that's done, what we're going to get is Tn equals ARn. Tn ends up to be, now we have to find out what A is, we don't know. But we know that T4 or T3 even, doesn't matter which one I take, T3 is AR2. Therefore, T3 is equal to A minus 3 squared, and we know that that equals minus 63. 6A equals minus 63. A therefore has to equal to minus 7. So the first term is minus 7 and the common ratio is minus 3. Expressed in terms of n, Tn and Sn. Well, Tn is ARn to the minus 1, which is going to be minus 7 bracket minus 3 to the n minus 1. Okay, Sn, and this is question 10. And then Sn is going to be A into 1 minus Rn, 1 minus R. Now in this case what we're going to get is minus 7 bracket 1 minus 3 to the power of n. Okay, all over 1 minus 3. And then what we're going to get is minus 7 over 4. Bracket 1 minus 3 to the power of n. Close bracket. Now guys, when you look at this, okay, if you multiply inside the bracket by minus 1. So we're going to multiply inside the bracket by minus 1 and we get 7 over 4 into minus 1 plus bracket minus 3 to the power of n. Okay? And then we can reverse that around, 7 over 4 into minus 3 to the power of n minus 1. Okay, so that's 2, 4, 8, 10.